Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. And welcome dear students to the fourth lecture of operating system. As you know that in last lecture we discussed multi-programming operating system and the reasons why we need multi-programming operating system. Today we are going to do some practical examples in order to understand the concept that the need of multi-programming operating system. Multi-programming operating system versus mono-programming operating system or uni-programming operating system, this is same. Here is an example that if operating system is mono-programming operating system, how much time of the CPU is wasted. And in next example we will do a practical example of multi-programming or system, that how much time is wasted of CPU in multi-programming operating system. Here is an example. This example says that there is a process which takes 40 milliseconds of input output or IO devices, and the same process need 10 milliseconds of CPU to complete its operation, meaning that this program requires 10 milliseconds of CPU for its execution and 40 milliseconds for input output devices. Let me clarify this example. Assume that this is a video to be played, so this video needs 10 milliseconds of a CPU to be run and 40 milliseconds of a loudspeaker and the screen to be displayed. So we are going to discuss that how much time of CPU is wasted during this process, and how much time of input output device is used and how much time of CPU is used. Now these are called chunks. These are called chunks, but you can say these are the milliseconds. You can start from this number it all the way from this very first one chunk to this chunk. This is total 40 milliseconds. It takes 40 milliseconds as it is written here, that this process starting. So what do you mean by start? Start means you click the process to be run. This is the point you clicked. Now this process needs 40 milliseconds of input output device, and then at this stage, which is 41 milliseconds, it's entered to the CPU, and you see 1 2 3 4 5 6 7 8 9 10 milliseconds are needed for this process of a CPU to be completed. Now we are going to check that how much time of a CPU is wasted and how much time of a CPU is utilized. Now the formula for CPU utilization is, this is the formula for CPU utilization. You see CPU utilization is equal to CPU time divided by total time multiplied by 100. You will get the CPU utilization time. So total time is actually the sum up of IO time and CPU time. So 40 milliseconds are required for input output device and 10 milliseconds are required for CPU. So the total time becomes 50 milliseconds, and the CPU time is 10 milliseconds. You see here 10 milliseconds. So 10 divided by 40, I think it comes 0.2, and then multiply by 120%. So the 20% time of CPU is utilized. Let me do it practically, this example, so that you can understand better. I will do it in this white board. Let's use it as a whiteboard, right? Okay, now look here. We have CPU utilization formula. The formula is that CPU CPU time is 10 milliseconds, right? And then divided by total time. So what is total time? 10 milliseconds of a CPU and 40 milliseconds of input output device. So total become 50 milliseconds. So divided by 50 milliseconds, and then you need to multiply this, whatever comes in 100 into 100, you will get the CPU utilization, right? Okay, now so 10 millisecond divided by 50, 10 divided by 50, let me have a, where is the calculator, so that you could understand better. I know that it becomes 0.2, so this is the calculator. 10 milliseconds divided by 50 milliseconds, it comes 0.2. Now multiply 0.2 into 100, multiply 0.2 into 100, so 20%. How much? It is 20%. So the CPU, this process actually uses CPU only 20%. How much percent? 20%. So if 20% time of a CPU is utilized, how much time is wasted? 80% time is wasted. 80% time of a CPU is wasted in a single, or you can say in a mono programming operating system. In mono programming operating system, 80% time of a CPU is wasted because there is no another program to be run, right? There is not another program to be run. You see here that the same formula is run here. Okay, now if you want to find out the CPU wastage time, so for CPU wastage time you can use this formula. CPU waste time is equal to IO time divided by total time multiplied by 100. If you want to find out CPU time, so you need to divide CPU time into total time. If you want to find out the wasted time of a CPU, you need to divide the input output time into total time multiplied by 100. So you see here, what is the IO time? IO time is 40 milliseconds divided by 50 milliseconds is total time. Total time mean IO time plus CPU time, right? IO time is 40 milliseconds and CPU time is 10 milliseconds. Now, so if you divide this 40 by 50, right, you will get 0. So, okay, now you need to multiply by 100 to get its percentage. So if you multiply the result of this, let me check first what the result comes of. No, look at here, 40 millisecond divided by 50 millisecond, it is 0.8. Now multiply this into 100, you will get 80%. 80% time of a CPU is actually wasted. 80% time of a CPU is wasted in this program. So what is the conclusion of this? The conclusion is that if a single program in a mono programming operating system which requires 10 milliseconds of a CPU and 40 milliseconds of a IO device is run, so 80% time of a CPU will be wasted. 80% time of a CPU will be wasted. Now if we run the same program in a multi-programming operating system, the result will be totally different. You see that for a single program 80% time of a CPU is wasted, because let's do it little bit logically. From this point all the way to this point, the CPU is doing nothing. This CPU is idle. This is why we call this time a wasted time, because if the CPU is doing nothing, so we consider this time as a wasted time, because the time of a CPU is very precious to us. We need to utilize its maximum capacity, the time of a CPU. Now in a mono programming operating system, because you can run only a single program, you cannot run another program at this point. That's why If you run this program, so 80% time of a CPU will be wasted. Now let's do it in the same program. We need to do it in a multi-programming operating system. Look at this example. Okay, in this example, assume that not the same program, but we have many programs, multiple programs. We have multiple programs. Now look at this one. We have program number 1, or you can say process number 1, but look, take it as a program number 1. This is program number 1. So what is the time of a program number 1 which requires a CPU to be utilized? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 milliseconds are required for program number 1 or process number 1, not program number 1, but process number 1. For process number 1, it requires 12 milliseconds of a CPU. Then it goes to the output device, so we don't care about the output device, whatever the output device is. Now there is another process which requires 1, 2, 3, 4, 5, 6 milliseconds of a CPU time. For us, CPU is very important. That's why we are only calculating the time of a CPU. And there is another process which requires 1, 2, 3, 4 milliseconds of a CPU to be executed. And there is another fourth process which requires 1, 2, 3, 4, 5, 6, 7, 8 milliseconds of a CPU. But this is a multi-programming operating system. So what do you mean you can run at the same time more than one program? So in this scenario, we are running 4 processes or 4 programs, right? We haven't actually discussed about the processing program. Inshallah, in upcoming lectures we will clarify this concept, that what is the difference between program and process. There is a big difference between program and process, but now in this lecture I am just using the name of a program instead of process, in name of process instead of program, because we haven't studied that yet. Okay, now let's calculate first the CPU utilization time. You see here, CPU utilization time is equal to CPU time of process number 1, process number 2, process number 3, process number 4. So you need to sum up this, divide it into total time. Now the question is, you might have doubt that why in previous example we only sum a single process. In this example we are actually summing up 4 processes. The reason is that was a single or mono programming operating system, meaning that you can only run a single program, and this is an example of a multi-programming operating system where you can run more than one programs. In this case we actually run 4 processes. We need to sum up these 4 and then divide it into total time. So now the question is, what is total time? So the total time is, you need to sum up first these 2 and then the rest of the input output time, IO time. Now 12 into plus 6 is equal to 18, 18 plus 4 is equal to 22, 22 plus 8 is equal to 30, 30, 31, 32, 33, 34, 35, 36. So the total time starting from this point all the way to this point is actually 36 milliseconds. So now 12 of first program, and then plus 6 of second process, 4th of third process, and 8th of fourth process, and then so these you need to sum up these, so this become 30, and then the total time of 30 plus 6 is equal to 36. You need to divide it by 36. You see here, so sum up the 30 divided by 36 and then multiply by 100, you will get 83.33%. Let me do it a bit in practical, right? Okay, Now this is a calculator. Let me open it first. Okay, look at here. We need to sum up first this 12 of first process, and then second process is 6. Second process is 6, and then plus 4, third one 4, and then 8 of this one, fourth one. You will get 30 divided by 36, because you need to sum up CPU time in IO time. So this is the total is 36. You will get 0.83 multiplied by 100. So you can see the result of this one. 83.333% time of CPU is utilized. Time of CPU is utilized, meaning that 83% of CPU is utilized in this scenario. Let me erase this first so that you can see it clearly. Okay, so in this example, 83% time of CPU is utilized. In previous class, 80% time of CPU was wasted. 80% time of CPU was wasted. In this case, 83.33% time of CPU is utilized. So you can imagine the difference, that how much time of CPU you can utilize in a multi-programming operating system, and how much time of CPU you can utilize in a mono-programming operating system, right? I will be giving you an assignment where you can find out in a mono-programming operating system okay, now let's find out the wasted time. So the rest time is wasted. So 83.33%. If you minus this from 100, you will get, I think, 17.90 33. You can say 63, I think. Yes, 63. So this is the time of a CPU wasted. This is the time of the CPU wasted. Let me do it practically for you. Okay, what is the time of the IO? IO time is 6 milliseconds. 1, 2, 3, 4, 5, 6. So 6 divided by total. What is total? Total is 36. So the total is 36. Okay, let me erase this. 6 divided by 36, you will get this one, and then multiply it into 100. You see, I'm so sorry, 16.66, not 17. 16.66% time is only wasted. So there is a big difference between mono-programming operating system and uni-programming operating system, that in mono-programming operating system more time is wasted, in multi-programming operating system less time is wasted. So I will give you an assignment that where you can calculate the difference between mono-programming operating system and uni-programming operating system. So this was an example of CPU utilization in CPU wastage. I think this is enough for this lecture, because I'm giving you an assignment where you can calculate. I will be uploading the assignment to Salam LMS, and you can download the assignment. It will be in a Word file, so then calculate it. I would like you to, it's up to you. So if you can do the mathematics in a Word file and then upload it, or if you want to do mathematics on a paper, then take pictures of a paper and insert your picture in a Word file, and then send that Word file to me. So this is enough for today. Thank you so much. Assalamu alaikum.